This video is about different representations of vectors. We need to be able to find the magnitude of a vector and the unit vector in the same direction of any given vector. We also need to be able to use these skills to solve problems. So first of all, vectors can be represented in different ways. So one of the ways they can be represented is as column vectors. So e.g. 2, 3. Using ij components, which are vectors of length 1 in the horizontal and vertical respectively. So that means I is going in horizontally and j is vertically. R theta, which is called the magnitude direction form. So R is the magnitude. Oops. R is the magnitude of the vector, which is the size of the vector, and theta is normally the angle it makes with the positive x-axis. And it can also be represented as a directed line segment. So for example, vector going from A to B can be denoted as little a. So we say A to B is equal to A. Okay, so we need to be able to solve problems using all these different representations of vectors. Write these vectors in ij and column vector form. So A, so if this is 45 degrees, then if I draw a line going horizontally, then this is also 45 degrees, because the right angle there, which means the one opposite the angle will be 15, because this opposite is so it's going to be 15 sine 45, and the one adjacent to the angle will be ka, so it's 15 cosine 45. Okay, you can use SOHCAHTOA to check that is correct. So that means my I component will be 15 cos 45, because I is moving horizontally. And my J component will be 15 sine 45 of J. That is equal to 15 times root 2 over 2i plus 15 times root 2 over 2j. If I write it over the same denominator, I get 15 root 2 over 2i plus 15 root 2 over 2j. They're all positive because it's moving in the positive x direction and positive y direction, so positive I and positive j. That is in ij component. If I were to write it in vector form, the same thing as the I component will go at the top and the j component will go at the bottom. So this was A. If I do B similarly, if this is 20 degrees, then because this is adjacent to the angle of 20, this will be the magnitude, which is 8. Adjacent means cos, so it's 8 cos 20. This length is opposite the marked angle of 20, so this is going to be so it's going to be 8 sine 20 degrees. So my I component is the horizontal component, which is 8 cos 20 of I plus 8 sine 20 of j. Now if I put this into my calculator, 8 sine cos 20 is 7.52 I, rounded to 2 decimal places, and 8 sine 20 is 2.74 j. And that in column vector form will be 7.52 at the top, 2.74 at the bottom. The next one, so we're doing C now. So again, we're going horizontally, it's moving in the positive direction. This length is adjacent to the angle, so it will be 20, adjacent means ka, so it's 20 cos of 25, I. So this is 20 cos of 25. Now, because we're starting from here and going there, we're going across to the right and down. Now, because we're going down, it's going to be negative. So negative. Again, it's going to be opposite the angle, so it's 20 sine 25. So minus 20 sine of 25. Now, if I put this into my calculator, I get 18.13 I minus 8.45 J. In column vector form, that's 18.13 on top minus 8.45 on the bottom. Now, just to re-clarify this, because it's going down vertically, the J component is negative. And D now. So D, we're going across. So we're going to start from here, end up there. So we're going across and then down. If this is 60, then this is 40 degrees. So this is going to be, because this is adjacent, that's going to be 5. Adjacent means cos ka, so cos 40. This is going down, so it's going to be 5, negative 5 sine of 40. I meant 30 here, because right angle is 90, 90 take away 60 is 30, so it's going to be 30 degrees, 30 degrees. So it'll be 5 cos 30i minus 5 sine 30j, which is the same thing if I put into my calculator as 5 root 3 over 2i minus 5 over 2j. So in column vector form, there'll be 5 root 3 over 2 minus 5 over 2. Okay, the resultant of vector A and B is parallel to vector C. So resultant means when you add A and B together, because it's parallel to vector C, it will be a scalar product, scalar multiple of C. Given that A is equal to 2i minus 3j, so I like putting it into column vector form. B is equal to 4pi minus 7pj. And C is equal to I minus j, so 1 minus 1. Find P. So A plus B is equal to lambda times C, which means 2 minus 3 plus 4p minus 7p is equal to lambda times 1 minus 1. I get two equations from this, so if I I get 2 plus 4p is equal to lambda times 1, which is lambda, and minus 3 minus 7p is equal to minus 1 times lambda, which is minus lambda. So if I call this equation 1 and equation 2, and if I do 1 add 2, I eliminate lambda, so all I'm left with is minus 1 is equal to minus 1 minus 3p is equal to 0, which means 3p is equal to minus 1, which means p is equal to minus a third. Okay, next one, the resultant vector of vector A and vector B is now parallel to vector I. So for this one, we've got A plus B is equal to lambda times I. Find P and hence find the magnitude of the I component. So this implies that 2 minus 3 plus 4p minus 7p is equal to lambda times 1, 0. Because if it's just lambda times I, it's lambda times I plus 0j. Which means I get the two equations, 2 plus 4p is equal to lambda, and minus 3 minus 7p is equal to 0. So from if minus 3 minus 7p is equal to 0, implies 7p is equal to minus 3, which means p is equal to minus 3 over 7. If I substitute p is equal to minus 3 over 7 into 3, then I get 2 plus 4 times minus 3 over 7 is equal to lambda, which implies lambda is equal to 2 over 7. Therefore, a plus b is equal to 2 over 7i, which implies magnitude of I component is equal to 2 over 7. Okay, next question. Given that C is equal to 3i plus 4j and D is equal to I minus 2j, find A, lambda if C plus lambda D is parallel to I plus j. So if I have, so C is equal to 3, 4, and D is equal to 1 minus 2. So C plus lambda D is parallel to I plus j, means it's parallel to mu times I plus j can be written as 1, 1. So mu times 1, 1. So I end up with the equation, I get 3, 4 plus lambda times 1 minus 2 is equal to mu times 1, 1. Which means I get 3 plus lambda is equal to mu, and 4 minus 2 lambda is equal to mu. Call this 1 and 2. If I do 1 take away 2, I end up with 3 take away 4, which is minus 1. Lambda take away minus 2 lambda, it gives you plus 3 lambda is equal to 0, which implies 3 lambda is equal to 1, which means lambda is equal to a third. Okay, part B. Mu times C plus D is parallel to I plus 3j, which is 1, 3. So parallel to lambda, another scalar multiple times 1, 3. Which means mu times C, which is 3, 4, plus D, which is 1 minus 2, is equal to lambda times 1, 3. Which implies I get the two equations, 3 mu plus 1 is equal to lambda, and 4 mu minus 2 is equal to 3 lambda. So if I multiply equation 1 by 3, then I get 9 mu plus 1 is equal to lambda. 3 lambda. Forgot to multiply everything by 3, common mistake. So 9 mu plus 3 is equal to 3 lambda. Keep the second equation as it is, which is 4 mu minus 2 is equal to 3 lambda. Call this equation 3 and 4 now. So 3 take away 4. 9 mu take away 5 mu gives me 9 mu take away 4 mu gives me 5 mu. And 3 take away minus 2 gives me 5 is equal to 0. 3 lambda take away 3 lambda gives me 0, which implies mu must be equal to minus 1. See now? C take away S times D is parallel to 1. So let's call it lambda times 1, which means C, which is 3, 4, minus S times 1 minus 2 is equal to lambda times 2, 1. So you get the equations 3 minus S is equal to 2 lambda, and 4 plus 2S is equal to lambda. So if we call this equation 1, times it by 2, then we get 6 minus 2S is equal to 4 lambda, and we've got 4 plus 2S is equal to lambda. So let's call it 3, this is 2, 3, 4. So if we do 3 add 4, then we end up with getting 10 is equal to 5 lambda, which means lambda is equal to 2. But we didn't want to find lambda, we want to find what S is. So that means 3 minus S, using the first equation, 3 minus S is equal to 2 lambda, which means 3 minus S is equal to 4, which means S is equal to minus 1. Okay, let's do D here. So D said T, if D minus T times C is parallel to minus 2I plus 3J, so minus 2, 3. So it's equal to parallel to minus 2I plus 3J, so it's equal to lambda times minus 2, 3. So that means D, which is equal to 1 minus 2, minus T times C, which is 3, 4, is equal to lambda times minus 2, 3. So I get the equation, the first equation I get is 1 minus 3t is equal to minus 2 lambda, and minus 2 minus 4t is equal to 3 lambda. So you take equation 1 and 2, I need to make the lambdas the same, so I'm going to times this one by 3, times this by 2, which means I end up getting 3 minus 9t is equal to minus 6 lambda, and minus 4 minus 8t is equal to 6 lambda. 3 and 4. So if I do 3 add 4, I end up getting minus 1 minus 17t is equal to 0, which means 17t is equal to minus 1, which means t is equal to minus 1 over 17. OABC is a parallelogram. P divides A to C in the ratio 3 to 2. So 3 to 2. O to A is equal to 2i plus 4j. So 2, 4. And O to C is equal to 7i. So 7, 0. A. Find in ij component column vector format A to C. A to C is equal to A to O plus O to C. Now A to O is in the opposite direction, so it's going to be minus 2 minus 4 plus 7, 0, which gives us minus 2 plus 7 is 5, minus 4 at the bottom. So that's in column vector form. In ij format, it's 5i minus 4j. B. O to P. O to P is equal to O to A plus A to P, which is the same thing as O to A plus 3/5 of A to C. O to A is just 2, 4 plus 3/5 of, well, worked out in part A, which is 5 minus 4, which ends up with 2 plus 3/5 times 5 and 4 plus 3/5 times minus 4. So I get 5 at the top and 1.6 at the bottom, which means I get 5i plus 1.6j. C is a to p, which is 3/5 of a to c. I've just worked this out already, which is 3/5 of 5 minus 4, which is equal to 3 and minus 2.4, which is equal to 3i minus 2.4j. Oops, j. Next question, A is equal to P minus Q, B is equal to QP, C is equal to 7.4. Given that A plus 2B is equal to C, find the values of P and Q. So that means P minus Q plus 2 lots of QP is equal to 7.4, which implies I get P plus 2Q is equal to 7, and minus Q plus 2P is equal to 4. So this is equation 1, equation 2. I want to make the Q's the same, so I'm going to multiply this one by 2. So the first one stays the same as P plus 2Q is equal to 7. Multiply the second equation by 2, I get 4P minus 2Q is equal to 8. I've lined up the P's and the Q's and the constants together, so it makes my life easy. So now if I add them together, 3 add 4, I end up getting 5P is equal to 15, which means P is equal to 15 divided by 5, which is 3. If P is equal to 3, then P plus 2Q is equal to 7, which implies 3 plus 2Q is equal to 7, which implies 2Q is equal to 4, which means Q is equal to 2. Next question, the resultant of the vectors A and B, so that is 3 minus 2 and P minus 2P, is parallel to the vector C, which is 2 minus 3. Find the value of P. So the resultant means you add it together, so 3 minus 2 plus P minus 2P must be parallel to 2 minus 3, which means it must be a scalar multiple of 2 minus 3. This means 3 plus P must be equal to 2 lambda, and minus 2 minus 2P must be equal to minus 3 lambda. So if we call this equation 1, equation 2, if I try to eliminate the P, I need to multiply the equation 1 by 2, which means I get 6 plus 2P is equal to 4 lambda, and minus 2 minus 2P is equal to minus 3 lambda. So if I do 3 add 4, I eliminate P, so all I'm left with is 4 is equal to lambda. If lambda is equal to 4, so if lambda is equal to 4, 3 plus P is equal to 2 lambda, which implies 3 plus P is equal to 8, which means P is equal to 5. Find the resultant of vector A and B. So A will be equal to 3 minus 2. B is equal to P minus 2P, which means it's 5 minus 10. So A plus B will be equal to 3 minus 2 plus 5 minus 10, which is 8 minus 12. So what is a unit vector? A unit vector is a vector of magnitude 1. How do you find the magnitude of a vector in 2 dimensions? So if A is equal to xi plus yj, then magnitude of A is equal to, we write two vertical lines like this, that means the magnitude of A is equal to the square root of the I component squared plus the y and j component squared, the square root of x squared plus y squared. So e.g., if you have A is equal to 5, 12, then the magnitude of A is equal to square root of 5 squared plus 12 squared, which is equal to 13. How do we find the unit vector in the direction of a given vector? So if A is equal to xi plus yj, which is equal to xy, then unit vector of A in the same direction is called A hat, is equal to, so I just have to write here, is equal to the vector A divided by the magnitude of A. So if I wanted to show an example with A again, e.g. if A is equal to 5, 12, then the unit vector of A will be 5, 12 divided by the magnitude of 5, 12, which is equal to 5, 12. We've already worked out the magnitude of 5, 12 is equal to 13. So it's equal to 1 over 13 times 5 over 12, which is equal to 5 over 13, 12 over 13 as a vector. So you can check if that is if that has magnitude 1. So the magnitude of 5 over 13, 12 over 13 will be equal to square root of 5 over 13 squared plus 12 over 13 squared, which is equal to 25 plus 144, which is 169 over 169, which is equal to 1. Which is equal to 169 over 169 square rooted, which is equal to 1. So it does have magnitude 1. Okay, let's do some questions now. Given that A is equal to 3i plus 4j, and B is equal to minus 2i minus 4j, first find the magnitude of A. So magnitude of A is equal to the magnitude of 3, 4, which is equal to 3 square root of 3 squared plus 4 squared, which is equal to 5. Find a unit vector in the direction of A. So unit vector of A is equal to A over the magnitude of A, which is equal to 3, 4 divided by 5. So it's the fifth times 3, 4, which is equal to 3 over 5, 4 over 5. C, find the exact value of the magnitude of 2a plus 3b. So first I'll work out 2a plus b, which is equal to 2 times 3, 4, plus minus 2 minus 4, which is 6 minus 2, which is 4, 8 minus 4, which is 4. So the magnitude of 2a plus b is the magnitude of 4, 4, which is equal to square root of 4 squared plus 4 squared, which is equal to square root of 32, which is 16, root 16 times root 2, so it's 4 root 2. Find the angle between the vector 4i plus 5j and the positive x-axis. So if it's 4i, it means it's moving in the I direction by 4 and j direction by 5. So it ends up moving like this. So we're trying to find the angle between the positive x-axis and this vector. We're trying to find this theta. So we've got opposite and adjacent. So tan theta is equal to 5 over 4. So theta is equal to inverse tan of 5 over 4, which is equal to 51.3 degrees. Vector A has magnitude 10 and makes an angle of 30 degrees to the right of J. So you've got something which has a vector that has a magnitude of 10 and it's making an angle. So this is J, obviously, and it's making an angle of 30 degrees. So my diagram is not drawn to scale, so be very careful with that. Which means if I draw a horizontal, then this will be equal to 60 degrees. So if I want to find the I component, it must be 10, because it's adjacent, it must be 10 cos 60. And because the J component is obviously opposite the angle, that must be 10 sine 60. So it must be 10 cos 60i plus 10 sine 60j, which is equal to 5i plus 5 root 3j. So that's an ij component. So the column vector must be 5 root 3. For each of the following vectors, find a unit vector in the same direction and the angle the vector makes with I. So a unit vector in the same direction, so if this A is equal to this, then A hat will be equal to A over the magnitude of A, which is equal to 8, 15 divided by square root of 8 squared plus 15 squared, which turns out to be 8, it's a vector and not a fraction, 8, 15 over 17, which is 1 over 17 times 8, 15, which is equal to 8 over 17i plus 15 over 17j. I'm putting in an ij component form because the question was in ij component form. So that was part 1. So part 2 would be find the angle that vector makes with I. So if it's going 8, so the 8i plus 15j, what angle does it make with vector I? So that means this 8i is going 8 in the horizontally. J is 15, so it's going 15 vertically. The angle it makes with I is basically this. So we're trying to find theta there. It's opposite and adjacent, so tan theta is equal to opposite, which is 15 over 8. So theta is equal to inverse tan of 15 over 8, which means it's equal to 61.9 degrees. Do the same thing with C. So the unit vector of C is equal to C over the magnitude of C, which is equal to minus 940 all over square root of minus 9 squared plus 40 squared, which gives us 41. So minus 9 over 40 divided by 41, which gives us minus 9 over 41i plus 40 over 41j. For part 2, we know if it's going minus 9i, then it's going, just from the starting point, it's going minus 9. So 9 this way, in the negative x direction. And then it's 40 going up. So 40, so we're looking at this. If it's the angle the vector makes with I, then I is the positive x, so we're trying to find out what this is. So we're trying to find out what theta is here. But before we can find out theta, we need to find this angle. So let's call this angle x. So let's call this x. So we've got opposite and adjacent, so tan of x is equal to opposite, which is 40 over 9. So x will be inverse tan of 40 over 9, which is 77.3 degrees. So now that we know what x is, theta must be 180 minus 77.3 degrees, which is equal to 102.7 degrees. Draw a sketch for each vector and work out the exact value of its magnitude and the angle it makes with the positive x-axis to one decimal place. So magnitude is equal to square root of 3 squared plus 4 squared, which is equal to 5. It's going 3i, so 3 in the positive x direction, 4j, so going up by 4. So like this, work out the exact value of its magnitude and the angle it makes with the positive x-axis, so it's to one decimal place, so this is theta. So we've got opposite and adjacent, so tan of theta is equal to 4 over 3. Theta is equal to inverse tan of 4 over 3. Theta is equal to 53.1 degrees. Okay, the same thing with minus 5i plus 2j. The magnitude is equal to square root of minus 5 squared plus 2 squared, which is square root of 29. If I were to sketch this out, it's going 5 in the negative x direction, and then 2 in the positive y direction. So it's going like this. We're trying to work out the angle theta, which is equal to here. First, we need to work out what x is. Tan x is equal to opposite, which is 2 over 5. So x will be equal to inverse tan of 2 over 5, which is equal to 21.8 degrees. So plus theta is the angle that it makes with the positive x-axis. X-axis is 180 take away 21.8, which is equal to 158.2 degrees. Vector A is equal to pi plus qj has a magnitude 10 and makes an angle theta with the positive x-axis, where sine theta is equal to 3 over 5. Find the possible values of q, p and q. If sine theta is equal to 3 over 5, what we have is a triangle with the angle marked theta. Opposite the angle must be 3 and the hypotenuse must be 5. So if I want to work out the adjacent, it must be 5 squared take away 3 squared square rooted, which is 25 take away 9. Square root of 16 is 4. So that must be 4. Now we know that the magnitude is not 5. Magnitude is 10. So what we need to do is we need to double all our values. So if we double here, that becomes 6. That is also 4. So 3, 3 is 6, yeah? So what we have is this triangle in front of us. 8, 10, and 6. Okay, so that means P, one of our values must be P is equal to 8 and Q is equal to 6, because obviously it's 8 horizontal, moving 8 horizontally and 6 vertically. Now if we think of our axes like this, what we do know is all are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cosine positive in the next quadrant. So another solution will be also here. So this theta will also give us another solution, even though it's obtuse, it will give us a solution. So that means here your x value will be -8 and your y value will be 6 still. So P is equal to -8 and Q is equal to 6 gives us another solution. So that's 2 solutions so far. Now you might think that the other two quadrants will give you solutions, but because we're measuring the angle theta makes the positive x-axis, even if we go here, it'll give us a solution, because positive x-axis means this angle here. What we normally measure is we measure all the way around here, which will give us a negative answer, but because we're working out this angle, it'll also be positive. It will always also give us a solution. So P is equal to 8 and Q is equal to -6 will also give us a solution. And similarly, for this one, because angle theta is the one that it makes, the smallest angle it makes with positive x-axis, that will also give us a solution. So P is equal to -8 and Q is equal to -6. So all 4 of these values give us solutions. So P is equal to ±8, Q is equal to ±6. In a triangle PQR, PQ is equal to 4i plus j, so that is 4, 1, and P to R is equal to 6 minus 8. A, find the size of angle QPR, so this angle X, in degrees to 1 decimal place. So first thing we need to do is work out the magnitude of all this. So the magnitude of P to Q is the magnitude of 4, 1, which is equal to square root of 4 squared plus 1 squared, which is equal to square root of 17. Then the magnitude of P to R is equal to magnitude of 6 minus 8, which is equal to 6 squared plus minus 8 squared, square rooted, which is equal to 10. So what we do have is P, Q, and R. We have P to Q is root 17, P to R is 10. What I need to do is work out Q to R. So if I want to work out Q to R, first I need to go Q to P plus P to R, which is equal to -4 minus 1 plus 6 minus 8, which is equal to 2 minus 9. Therefore, the magnitude of Q to R will be equal to the magnitude of 2 minus 9, which is 2 squared plus minus 9 squared, which is equal to square root of 85. So here I've got square root of 85, and I'm trying to find out x. So I can use the cosine rule. So using cosine A is equal to b squared plus c squared minus a squared over 2bc, I get cosine of x is equal to root 17 squared, which is, let's just write it out, root 70 squared plus 10 squared minus root 85 squared all over 2 times root 17 times 10. So x will be inverse cos of all that, which is 17 plus 100 minus 85 all over 2 times root 17 times 10. And I get a value of 67.2 degrees from my calculator. So this was part A. For part B, so area is equal to half AB sine C, which implies this must be, because this is C, this must be A, and this must be B. So area is equal to half times root 17 times 10 times sine 67.2, which works out to be 19.0 units squared.